Okay, so what we're going to look at here is the common oxidation and reduction equations that we need to be familiar with in level 3 organic chemistry. Now, if we are going to look at oxidation reactions, what we're interested in is primary and secondary alcohols. And just as a reminder what a primary and a secondary alcohol is, a primary alcohol is an alcohol, a molecule where the alcohol, the OH group, is the carbon it is bonded to one other carbon. A secondary alcohol is when the OH group, the carbon it is bonded to two other carbons. Now, in this case, I've just drawn a generic what's called an R group. Now, an R group usually represents any other part of the organic molecule that contains carbons and hydrogens. So it could be a methyl group, an ethyl group, a propyl group, it could be a ring, a hexagon ring. But when I have the wee prefix here R1, it means, okay, it's one type of random group. If I have, for the secondary alcohol, an R1 and an R2, it just means I've got a random group on one side and a random group on the other. They are independent of each other, so they could be the same or could be different. So this is why these generic ones are just put here at the moment. Now, alcohol functional groups can be turned into ketones and aldehydes using oxidizing agents. And the common oxidizing agents are acidified permanganate, MnO4 minus/H plus, or acidified dichromate. Now, sometimes acidified permanganate can be written KMnO4/H plus, and sometimes acidified dichromate can be written K2Cr2O7/H plus. So if we add that to a secondary alcohol, what happens is we are oxidizing this, and in essence, what the change that happens is we form another oxygen-carbon bond. So if you look at the secondary alcohol, there is one carbon-oxygen bond from the carbon to the oxygen, but it will turn into a ketone, and now the ketone has a double carbon to oxygen bond, or it has two of those bonds. It has been oxidized. Another way to look at this is if we look at the secondary alcohol, it has two more hydrogens in the ketone. It has lost two hydrogens, and when organic molecules lose hydrogens, they are getting oxidized. So you can say, you can look at it either, I recognize it's oxidation because it's gained more oxygen to carbon bonds, or I recognize it's oxidation because it's lost hydrogens. So a secondary alcohol will turn into a ketone, and a primary alcohol will turn into an aldehyde. Okay, again, we can see that what we've done is we've added another carbon-oxygen bond. It's a double bond here. Now, with an aldehyde, this is actually can be oxidized again itself. So we can make an alcohol turn into an aldehyde, and an aldehyde can further react and turn into a carboxylic acid. Now, notice the carboxylic acid has 1, 2, 3 carbon to oxygen bonds. It is the most oxidized, then aldehyde, and then alcohol. So it goes through a process of least oxidized through to the most oxidized. Now, the aldehyde can have the extra carbon to oxygen bond because it's at the end of the molecule. The ketone, we cannot make another carbon to oxygen bond without destroying the structure of the molecule. So it can only be oxidized to one step. We can also, for any of the ketone or aldehyde, turn it back into the alcohol. Okay, we can reduce it, and we can reduce it by adding sodium borohydride. So we can turn a ketone back into an alcohol, a secondary alcohol, and what we're doing is reducing the number of carbon-oxygen bonds. So we go back to an OH and a carbon-hydrogen here, and we can do the same with an aldehyde to an alcohol. So we're going to look at examples of these so we're familiar with those. And remember, we're using sodium borohydride, and that's used. So when you're looking at these molecules and reaction schemes, we will be looking for MnO4 minus/H plus or Cr2O7 2 minus H plus to recognize the oxidation is happening, or NABH4 to recognize that reduction is happening. Right, let's look at some oxidation of alcohols. In this case, we're going to look at primary alcohols. So if we use permanganate, acidified permanganate, then what we're going to do, remember when we looked at the previous generic scheme, then we had our alcohol group, our primary alcohol, first gets oxidized to an aldehyde. It increases the number of carbon to oxygen bonds, and it produces this carbon double bond oxygen at the end of the molecule. Now this would be just an intermediate. So if permanganate was sitting in a mixture with aldehyde, first it would react with the alcohol to turn it to an aldehyde, and as soon as it makes the aldehyde, it would go on and do a second reaction, oxidizing reaction, and turn it into a carboxylic acid. Now there is an example where we'll look more closely at this and see how we can interrupt this series of reactions so we could collect the aldehyde just by itself. So we can carry out this reaction using permanganate as the reagent, or we can use acidified dichromate. In this case, this is a completely different molecule. It has a different framework, but it still has a primary alcohol on the end here. That primary alcohol will turn into the aldehyde, and the aldehyde will turn into the carboxylic acid. And these are the examples of oxidation that we need to be familiar with. Okay, we also need to be familiar what happens with a secondary alcohol. And with a secondary alcohol, again, we can use permanganate acidified or acidified dichromate. In this case, we're talking about secondary alcohols. So the OH is off a carbon in the middle of the chain. If we make an extra oxygen bond, it would go to a ketone. So we start with a secondary alcohol and we go to a ketone. We cannot oxidize ketones. They are an end product for the oxidation reactions because there are no more hydrogens for this carbon to get rid of to make another carbon-oxygen bond. So the ketone end of the road for oxidation from a secondary alcohol. If we look at a tertiary alcohol, and this is a tertiary alcohol, you can see that the OH group here is attached to a carbon that itself is attached to 3 other carbons. There is no way that we can make another carbon-oxygen bond because the carbon is only allowed 4 bonds, and it already has 3 bonds utilized in connecting to 3 other carbons. It can't shed a hydrogen to make another bond, so it will not be oxidized at all. Tertiary alcohols are not oxidized by permanganate or acidified dichromate. Okay, what about aldehydes? Well, as we saw in the previous, in the slide 2 slides ago, an aldehyde is an intermediate product when we oxidize a primary alcohol. If we were just to start with an aldehyde by itself, of course, it can go through the step of oxidation. And permanganate or dichromate can oxidize this into a carboxylic acid. Also, aldehydes can actually be oxidized by weaker oxidizing agents. So permanganate and dichromate are very good at oxidizing things, but there are 2 other solutions that we need to be aware of. Phenylene solution, it is said to be a weak oxidizer, and that means it will oxidize an aldehyde to a carboxylic acid, but it is not strong enough to oxidize an alcohol to an aldehyde, or a primary alcohol to an aldehyde, or a secondary alcohol to a ketone. Now, Phelyne's reaction is actually, we start with an aldehyde here, and we're adding copper ions in the presence of hydroxide ions, and they will oxidize this aldehyde to a carboxylic acid. And actually, the color changes from blue copper ions to orange copper oxide solid. The next reaction also that can happen is called Tollen's reagent. Now, Tollen's reagent is also a weak oxidizer. It will not oxidize alcohols, but it will oxidize carboxylic acids. And in this, sorry, not carboxylic acids, aldehydes. And in this case, this is an aldehyde group. It will be oxidized and turned into a carboxylic acid. Now notice here we have this ion here that is silver ammonia ion. This is called this is a complex ion, okay? And this complex ion actually will turn into silver metal when this reaction happens. And this is sometimes called the silver mirror test because it produces silver metal that deposits on a piece of glass and producing a mirror. Okay, so we know that alcohols can be oxidized to aldehydes, aldehydes to carboxylic acids, or we can oxidize secondary alcohols to ketones. But remember, we said at the start we can actually do the reverse reaction as well. So if we add sodium borohydride, okay, we can take what is an aldehyde functional group and we can turn it back into a primary alcohol. Also, we could take a ketone functional group and turn it back into a primary alcohol. And this is the opposite reaction to the oxidizing reaction, and this is why it's called a reduction. If we remember that oxidation and reduction are opposite reactions to each other. Okay, let's see how we understand this work and see if we can do a couple of reaction schemes. Okay, just to check that you understand everything we've been doing so far, what I want you to do is just pause the video, see if you can write in the missing molecules, and then we'll just check to see whether we got those right. Okay, so we can see that we have quite a lot going on. We've got arrows going from one molecule to another. Now the reason, remember, there are two arrows going from the secondary alcohol to the ketone is you can either oxidize it using acidified permanganate or acidified dichromate, or you can reduce the ketone back to an alcohol. So you can oxidize the alcohol to a ketone, or you could go back the other way and reduce a ketone to an alcohol. Now in this case, they've given us the ketone, so we can work out what is the alcohol that would be produced when it's reduced, or we could think about it the other way, what would be the alcohol that would produce this ketone. Of course, it will have the OH functional group coming off the first carbon, and it would look like this. And next one. Okay, so we have the primary alcohol here. If you have a look, you can see that the OH is on the right hand side here. This is the OH functional group. Now this is the only functional group that is going to change. The oxidizing agents only affect either aldehyde or OH functional groups. They can oxidize double bonds by adding OHs, but we don't have any double bonds here. So we're going to oxidize this functional group here, and everything else in the molecule should stay exactly the same because it's just the framework or the skeleton of the molecule. So I'm going to draw that up here. It looks the same, but what I've done is made a double bond oxygen. So I've still got the hydrogen that was at the top here, but I've just added another carbon to oxygen bond here. Now this is my aldehyde. It can do one more step. It can be oxidized by one more step to the carboxylic acid. It will keep the same framework. The only difference will be it will now be a carbon double bond oxygen and an OH and produce the carboxylic acid. And this is a summary of oxidation and reduction reactions. We need to know level 3 organic chemistry.
Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.